Hey Internet, welcome to Solid Mechanics tutorial. This is a original made-up question. You won't find it in textbooks. We have two cylindrical rods joined XY and YZ. So XY is the orange one, YZ is the blue one. We got two diameters. The orange diameter is D1, which is 60 millimeters, and the diameter for the blue one is 100 millimeters. It's not to scale, obviously. We want to find the average stress at the midpoint for XY and YZ. So we have pressures of 120 kilonewtons going one way, and we've got two 250 kilonewton pressures going the other way. We also have a length of 1.8 meters for XY and 2.4 meters for YZ for the length of the rods. Alright, draw your free body diagram, your FBD for step 1. This will help you visualize the problem. Next, list all the given values and the unknown. This will help you figure out what formulas to use. Step 2, find the formula for XY for the average stress. So stress is equal to pressure divided by area. This symbol here is sigma. Sigma for stress. So pressure is given, we want to find area. So step 3, find the area formula for XY. So the generic formula is going to be pi divided by 4 multiplied by d squared because it's a cylindrical rod. Step 4, find the area. So we're going to convert our diameter to meters from millimeters by dividing by 1,000. There is 1,000 millimeters in 1 meter. We get pi divided by 4 multiplied by 0.06 meters squared. We get 218.16 meters squared. Step 5, find the average stress for XY for part A. So we know there is 120 kilonewtons in tension because it's going one way and there's no other forces or pressure on the other way. So we plug it in. We've got 120 kilonewtons divided by 218.16 meters squared. So that's 550.05 Newton meters squared. 1 Pascal is equal to 1 Newton meter squared. So it is equal to 550.05 pascals, or PA. Repeat the same process for YZ. Note that we have pressures or forces going in the opposite direction, so we need to account for that. Find the formulas for your area and the stress formula. So it's the same, so repeat the process. So the area is 78.54 meters squared. So we just convert the 100 millimeter diameter to meters, which is 0.1. Plug it into your equation and you'll get that answer. Step 9, find the average stress for YZ for part B. So we've got 120 kilonewtons minus 250 kilonewtons going in the opposite direction, which will be minus 380 kilonewtons. So just coming back to the FBD, we've got pressures going this way, pressures going this way. So sometimes people say pressure and forces are used interchangeably, but since the symbol is P, we're just going to say pressure. Okay, so that's where the pressures are coming from. So our answer for the stress is minus 4,838.29 Newton meters squared, or minus 4.8383 kPa. Okay, disclaimers, the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Thanks for watching. Like and subscribe if you want to support me. Become a member or drop a super thanks. Leave a comment below if this was helpful. Until next time, see ya.